A nuclear reactor doesn't explode like a bomb because of three fundamental reasons. The fuel is completely different, the design works in the opposite direction, and the physics simply won't allow it. Let's unpack each of these. Reason 1. The fuel is not the same. Think of fuel like coffee. A nuclear bomb needs espresso, an incredibly concentrated, ultra-potent shot. A nuclear reactor runs on something closer to a mild drip coffee. Same beans, very different strengths. Both reactors and bombs use uranium, but the critical difference lies in how concentrated, or enriched, that uranium is. Nearly all uranium found in nature is a form called U-238, which isn't very reactive on its own. A more reactive form, U-235, makes up less than 1%, 0.7% to be precise, of naturally occurring uranium. Enrichment is the process of increasing that percentage. Commercial nuclear power plants use uranium enriched to just 3 to 5% U-235, according to the U.S. Department of Energy. Nuclear weapons, on the other hand, require uranium enriched to over 90%, or use plutonium instead. That's not a small gap. It's the difference between a campfire and a wildfire. To put it plainly, reactor fuel, by law and by physics, simply cannot sustain the kind of explosive chain reaction a bomb needs. As the World Nuclear Association confirms, a commercial power reactor cannot under any circumstances explode like a nuclear bomb. The fuel enrichment is nowhere near sufficient. Reason 2. The design does the exact opposite of a bomb. If a bomb is designed to release as much energy as possible in a fraction of a second, a reactor is engineered to do precisely the opposite. Release energy slowly, steadily, and under complete control, over years or even decades. Imagine squeezing a tube of toothpaste. A bomb squeezes the entire tube in one violent burst. A reactor is more like a precision pump that releases exactly 1 millimeter at a time, every single day, for 20 years. Every component in a reactor, from the fuel rods to the control rods to the cooling systems, is built specifically to limit the reaction, not amplify it. Control rods, for instance, are inserted into the reactor core to absorb neutrons, the particles that keep the chain reaction going. Pull them out a little, the reaction speeds up. Push them in, it slows down. It's like having a dimmer switch for nuclear energy. Bombs have no such mechanism. They're designed for one outcome only. Reason 3. The physics won't allow it. Here's where it gets fascinating and reassuring. Reactors are built with what physicists call a negative temperature coefficient. In plain English, if the reactor starts getting too hot, the reaction naturally slows down on its own. Reactors also have multiple physical barriers between the radioactive fuel and the outside world. Ceramic fuel pellets, sealed metal tubes, a thick steel pressure vessel, and a reinforced concrete containment structure with walls at least 1 meter thick, according to the World Nuclear Association. That's 4 layers of protection, each one independent of the others. Now, you might be thinking of the HBO series Chernobyl, which depicted the catastrophic 1986 disaster at a Soviet reactor. The exact sequence of events has been debated by scientists for decades. What's agreed is that a massive power surge triggered a series of explosions, likely involving steam and possibly a runaway nuclear reaction, followed by a graphite fire that burned for days. It was an industrial catastrophe of terrifying scale, made worse by a fatally flawed reactor design and a cover-up culture. But even at Chernobyl, there was no nuclear bomb-style explosion. The reactor didn't detonate like a weapon. It ruptured, burned, and released radioactive material into the atmosphere. In over 20,000 cumulative reactor years of commercial nuclear operation across 36 countries, there have been only 3 significant accidents: 3 Mile Island, Chernobyl, and Fukushima, and none of them produced a nuclear explosion. So why does the confusion about nuclear reactors exploding like bombs still persist? Largely because of how nuclear energy is portrayed in popular culture. From movies to television, mushroom clouds and reactors are often shown in the same breath, which conflates 2 very different technologies. The clearest way to think about it is this: a nuclear reactor and a nuclear bomb are related the way a controlled campfire is related to an explosion at a gas refinery. Both involve fire, but one is designed to burn steadily and safely. The other is not designed to be safe at all. Understanding that distinction isn't just reassuring, it's essential for anyone living in a world where nuclear energy will play a growing role in powering a cleaner future.